There's going to be a lot of kind of background information in this chapter, history of chemistry sort of stuff that I'm not going to test you on. I'm not going to ask you for the names or dates of any of the scientists. I'm going to talk about them, though, because it's important. So in terms of what do I need to know for the exam on this chapter, I would encourage you to look at the practice questions, the exam practice questions. So radioactivity was discovered in 1896 by Antoine-Henri Becquerel. So there are substances that phosphoresce. They'll glow green, especially in the dark. And so they observed that this happened, and they was like, well, why is that glowing? What's happening here? So his hypothesis was that that was the emission of X-rays. So what he did is he took some potassium uranyl sulfate crystals, exposed them to sunlight, because that's how you get these things to phosphoresce, and then he placed them on a covered photographic plate. So no light could reach the photographic plate, just those crystals were there. And the plate showed, like this, a dark spot where the crystals had been. So these crystals are exposing the photographic plate. So it's like, cool, hypothesis confirmed. He presents his results to the French Academy of Sciences, but then later realized, no, that wasn't right. And just a note about science. In science, we give our best estimate, our best hypothesis of what's true based on the current knowledge. So when you get new information, you do not stick to your original hypothesis just to be consistent, right? Like new information, let's reevaluate. Oh, I was wrong. No shame in that at all. So he discovered later that he was wrong. And so he retracted his results. And what caused him to do that is that he discovered that that dark exposure spot formed even if the crystals had not been exposed to light and there was no phosphorescence. So there was something about the crystals that were exposing the photographic plate, and it had nothing to do with the phosphorescence. So the crystals themselves were emitting something. Those crystals had uranium in them, and so he called these uranic rays. Marie Curie was one of the first women in France to pursue doctoral work. I mean, she really, really was a pioneer in her time. Women were just not encouraged. In fact, they were actively discouraged from doing anything like that. She discovered two new elements in the process of looking for other substances that emitted uranic rays. And these elements are polonium and radium. And it used to be, you discover an element, you get to name it. So polonium was named for her home country of Poland, and radium was named for the high level of radioactivity. Radium actually glows and emits heat. And so that's kind of this stereotype that we have of radiation. Oh, you're going to glow in the dark, right? Well, radium does glow in the dark. And so this is a watch face. And the reason that the markings on this watch are glowing in the dark is that there's radium in the paint. So we used to walk around with watches giving off radiation on our wrists. And what was really bad is that often women in the factories that did the painting of this, they didn't know any better. They'd lick the brush to get a nice fine point, and so they were actually ingesting radium. Oh, it's really bad. Anyway, Marie Curie changed the name of uranic rays to radioactivity, which is what we call it today. She got the Nobel Prize in Physics in 1903, along with Becquerel and her husband Pierre, for the discovery of radioactivity. And then in 1911, she received the Nobel Prize in Chemistry for the discovery of polonium and radium. And this is a picture of her with her two daughters.